All right, here's a problem where we're given a piecewise function, and we are asked to find the values for a and b in order to make f of x continuous and differentiable. Now, they don't mention at what x value, but we could take a look here and notice that at x equals 2, that is when one piece of the function ends and the other begins. So that's where we have to make sure we take a close look at this. So for continuity, we are often asked to figure out how to make a function continuous, and that is a pretty easy step. We can take this function here, ax to the fourth plus 5x, and we can set it equal to this function here, bx squared minus 3x. Now we know these functions aren't actually equal to each other, but when we plug in x equals 2, that actually enforces these two function heights to be equal at the value of x equals 2. Now the reason why that's so important is because now we can plug in x equals 2 and see where this problem takes us. So if you plug in 2 to all of your x values, you get a times 2 to the fourth plus 5 times 2 equals b times 2 squared minus 3 times 2. Make sure you know your powers of 2 in this question. 2 to the fourth ends up giving you 16a, plus 5 times 2 is plus 10, equals 2 squared, of course, is 4b, minus 3 times 2 is 6. Now, to be honest, there's a lot of different directions this problem can go, because we can't solve for a or b in this equation. We only have one equation with two unknowns. So in a situation like this, I would solve for either the variable a or b, whichever one feels more convenient. So if I begin this problem by adding 6 to both sides, that'll give me 16a plus 16 equals 4b, in which case I notice that if I divide both sides by 4, this actually gives me a convenient equation of 4a plus 4 equals b. Now we could have solved for a as well, or we could have solved for neither one, but no matter how you approach this question, you're going to get stuck somewhere with an equation that doesn't have an answer for either a or b. So this is where we now transition the problem to look at the differentiability. So for differentiability, we will need the derivative of this piecewise function. So f prime of x in this problem here is piecewise. And for the first function, ax to the fourth plus 5x. If you use the power rule there, that will give you 4ax cubed plus 5, as long as x is less than 2. For the bottom piece, we can get 2bx minus 3, so long as x is greater than 2. Notice for both of those derivatives, I treated a and b as constants, and I simply used the power rule as we've learned already. So now for differentiability, we can take each of those pieces now and take 4ax cubed plus 5 and take 2bx minus 3, and we can set those two derivatives equal to each other, again, when x is equal to 2. This forces the function to not just be connected, but to also be smooth. That creates two equal slopes from the left and right, giving us a smooth connection. So once again, we can plug in 2 into this new problem for each of our x's, which gives us 4a times 2 cubed plus 5 equals 2b times 2 minus 3. Again, multiplying these out, 2 cubed gives us 8 times 4 is 32a plus 5 equals 4b minus 3. Now, once again, we can't solve this equation on its own with two unknowns, but it would be convenient if you could solve for either one of the two variables. And since I solved for b here, I'm going to solve for b in this case again. So I'm going to add 3 to both sides, and that gives me 32a plus 8 equals 4b. And again, conveniently, if I divide both sides by 4, I end up getting 8a plus 2 equals b. Now, once again, neither of these equations gives us an answer on their own, but together I can use systems of equations in order to solve this question. So the idea of a system is now whenever you want to replace something, as long as you know what the value is that you can replace it with, you can substitute this in anywhere that has the same value. In other words, if b is equal to 8a plus 2, then in the other equation, I can replace b with that 8a plus 2. So my new equation that I'm going to solve together in this system is 4a plus 4 equals 8a plus 2. It's an 8. So now I have an equation with just one variable, and to solve this just requires some simple algebra. Let me first subtract 4a from both sides, giving me 4 equals 4a plus 2. Then I can subtract 2 from both sides, giving me 2 equals 4a. And finally, dividing by 4 on each side gives me a equals 1/2. That is an important answer. Let's highlight it here. And that's one of the answers we need for this question. Now, after you solve for one variable, it actually is quite easy to solve for another. Let me pick one more color here. Knowing that a equals 1/2 means that we can solve for b by either plugging it into this equation here or this equation here. It's really up to us. So I'm going to use the first one, which gives us that b is equal to 4a plus 4. And if I substitute in our answer for a of 1/2, notice now I can get my answer pretty quickly as 2 plus 4, or in other words, 6. So b is equal to 6. Highlighting that gives me my two values for a and b, such that f of x is continuous and differentiable. If you'd like some practice solving a system of equations by using continuity and differentiability, check this problem out and check the comments for the values of a and b.